So, Dr. Ben-Dor, thank you so much for joining me today.
Well, thanks for having me.
It's an absolute pleasure. Could you just kick us off by telling us a bit about your background and what you do today?
Sure, I'm an Israeli, and I studied economics and I studied business, and I worked in the commercial enterprise until I was 52. At 52, I decided to retire, and I loved hunter-gatherers since my university days. So I decided to study, to go to university and to study. Got myself a PhD uh, in human evolution, in archaeology, in fact, but really the association between human evolution and nutrition. That was my area.
Uh,
And I've read a lot about nutrition, about evolution. And since then, I've written quite a few papers on the subject, and I'm still researching it. I'm still, in the end, I got to have a very, very wide-ranging theory about human evolution and why we actually evolved to become the way we are. And I'm trying to support now this hypothesis, this theory.
Well, that leads us very nicely onto our first question, which is if you can lay out for us how exactly you do see human evolution.
Okay, so everybody starts with the monkeys, and chimpanzee is a good model because it's the closest relative that we have. And so we were on the eating fruit and leaves on the trees, and then we came down from the trees. That was about 6 million years ago, and gradually we became bipedal. So we walked on two legs instead of four, and the species before us, Australopithecus, actually is like a chimpanzee that walk on two legs. And about 2.5 million years ago, our brain started to grow at quite a fast pace in evolutionary terms. So we started with a chimpanzee has about 400 cc volume in the brain, and the first human that there's argument about that too, whether it is the first human or not, but Homo habilis had 650 cc's, and then the next species had started with about 900 cc's, and then ended up having 1,200 cc's. So it's like a 50% steps. And if you come to nutrition now, so I think it's quite agreed upon that really Homo erectus, so it's about 2 million years ago, was a hunter. There are some arguments about the previous species, Homo habilis, but for Homo erectus, there's still also arguments about Homo erectus. I mean, there will always be people, more conservative, but I think the majority now accept the fact that Homo erectus was a hunter. You find a lot of bones with the stone tools. So, and a lot of marks on the bones and on the stone tools that they were used to get meat and all kind of meat and marrow from the bones.
And just to make a connection there, so because you've talked about in 2.5 million years ago, that's when we start to see this brain growth.
Right.
And then we're talking about sort of hunting becoming a major factor in nutrition. So
Right.
was that a main contributor in that brain growth, the introduction of hunting?
Well, the evolution doesn't work that the hunting is contributing. What happens if we go by the evolutionary theory is that first you start with a population that have, you know, a diversity. So some of them had, I don't know, 650, some of them had 700, and some of them had 600. So the 700 people were more successful in hunting. So they survived, and they had a diversity or a variety in which their offsprings, some of them had 750 cc's. So in the end, because you need the brain to hunt. Hunting is as opposed to collecting and gathering plants. Gathering plants, you know, doesn't require a lot of intelligence.
Tell that to the vegans.
Yeah, and yeah. There are papers. One paper in particular which says meat made us human, but it's not the availability of not eating the meat it's the need to obtain food that is really selecting the people that are most, or any animal, or in our case, people that are more adapted or better adapted with higher brains to get the animal. So in the beginning, the feeling is that at the beginning, humans were like scavengers. So for that, again, you don't need that much brain. You need more brain because you need to handle the tools to break the bones and get the marrow out of the bones. This is the theory. But if you really want to catch the animal, then you need you need to know more about the environment. You need to know about the where is the animal, how it moves, etc., etc. You need to, and then you need a larger brain if you want to to trace the animal, to track the animal. So yeah, so that's the idea. That's the theory. How we got the larger brain and how we got to the level of Homo erectus. Now, Homo erectus was already a fully fledged carnivore. This is also, I think, quite agreed. I don't, there's no meeting and voting. So I can't say that the whole, all the paleoanthropologists agree with that. But if you read the papers, most of them do, I think, agree. The question is then, so if Homo erectus with a 900, 1,000, 1,100 cc was already a full carnivore, how come we have now 1,450 cc? So why did our brain continue to grow? And that's the question I'm dealing with in the last 2-3 years.
Do you and what do you posit as the reason for that?
The reason is that the animals, the prey became smaller, and he sort of probably, I'm not saying, it's not vital for my theory, but probably the fact that he specialized in hunting large prey caused that large prey to disappear or to be reduced in abundance. So you had to hunt smaller prey. And the difference between large prey and smaller prey is that smaller prey escape, large prey don't. So if you're going to hunt an elephant, he just is not used to be escaping smaller animals. He's not used to, or a rhino or a hippo. Okay, they are not escaping. their speed is lower than the speed of a lion. So they don't rely on escaping. And humans could hunt them, and the method is to limit their movement somehow. Let's say you dig a hole and cover it with leaves, and they fall into it or something like that. And once they are as they say, disadvantaged, then you can kill them quite easily. Actually, just as long as you make them bleed, you can wait. You're not in a hurry. However, if you want to hunt a smaller animal, you have to cause it enough bleeding so it cannot run away long distances. And for that, you need higher technology. You need to know more about the animals because they do run away, and you have to follow them, and you have to track them. So you need a lot of information about nature and about technology. So that's why I think the brain grew from 1100 cc's to actually to about 1600 cc's. Now it's less. Now it's 1450. So it went down. The size went down at the end of the Paleolithic.
Well, that's the connection that I'm just thinking there is that there's the evolutionary stressor of smaller prey and I guess higher energy expenditure needed to catch that prey. Do we see corresponding morphology changes aside from brain size that come into humans as we see sort of the size of prey decrease?
No.
Why would that be?
I tell you why not. Because really we solve the problem with technology, not with the morphology. This is and this is, by the way, happening until today. We are solving problems with technology and not morphology, because morphology takes so much time to adjust, to adapt. And so I think as Homo erectus, we already had enough morphology, or we had the right morphology. There are many changes that happen that allow us to run, for instance. Again, you don't run to gather plants. The only reason you adjusted to running, including increased sweating and a lot of like, there's one paper with like 22, Lieberman paper with something like 22, separate adjustments or adaptations to running. So, and there is adaptations to throwing spears. But these all happened with Homo erectus. I can't say that there are, evolutionary adaptations morphologically to hunt. They're all in the mind. The mind allows us to trace them, to track them, to understand nature enough so that we can actually expect where they would go instead of just looking at the spurs. So, yeah.
And I want to roll back to your first paper, the sort of Man the Fat Hunter in 2011. And because much of this and these conversations that we're having is trying to understand what is appropriate human nutrition today, because we have supermarkets that are just full of things that are food-like substances, but potentially not food. And people are trying to understand what's the correct nutrition to be healthy today. So when we roll it back 2.5 or 6 million years ago, however you want to talk about the sort of our adaptations, what was it about sort of the large prey hunting, and what was it about that we've either evolved to need those different macronutrients, either the fats or the proteins or anything in between? What was it about those large prey and our previous nutrition can inform us about our nutrition today?
Right. So, well, evolution goes this way. So apparently plants were the main food of the previous species, right? Australopithecus. But something changed in the environment. So there were less of that and more of animals. There was a process of, increasing the size or the range of savannas. And savannas carry a lot of fauna, but not that much flora. So if you go to Serengeti, for instance, and you look for some plant foods, you'll have to look hard. But boy, there are so many animals in there. So I think this is the change, and it's not my theory, but this is the change. So we needed, if we wanted to survive, we just needed to adjust and to evolve, and this is evolution. So large animals were, savanna actually holds large animals because they have like some advantages. Being large provides some advantages, especially in savannas. And by the way, elephants actually create the savannas by knocking down trees. Like an elephant in Kruger Park, so they were following them at one stage. He knocks about 1,600 trees a year.
Wow.
Yeah, it's like a farmer. He prepares
Deforester.
yeah, he prepares the land,
Mm.
So there was this availability of large animals, and we evolved to take advantage of the change.
Mm. And that's so counter to what we hear, because I mean, we've developed and we've evolved over such a long period of time that we hear so much today in our very small snapshot window where we have modern media and everything in between, but the last 100 years or 50 years telling us that fat is bad for us. But these large prey animals, from my understanding, they were covered in fat, and as carnivores, the way we developed, we went for the fat first. That was like our main calorie source.
Look, yeah, it's funny, this anti-fat sentiment. I thought it should go, it should disappear for quite a long time ago, because it was pushed or by Ansel Keys, and since then it was already proven that he was like I don't want to use too many
Charlatan.
bad words. Yeah. So it was not serious. It was not a serious. I mean, scientifically speaking, this is terrible that people are still talking or thinking about it. It's really terrible. If you understand nutrition, what is the nutritional process? Let's go through it for 1 minute. So you eat something, whatever. Let's say you eat carbohydrates. And the body knows that you will need it for the whole day. Let's say you have 1 meal a day, so you eat a lot of carbohydrates. So what happens to them? So part of it, your insulin goes up, and they are getting pushed to the cells, and the cells use the glucose as a fuel. Okay, the rest turns to fat, right? What happens to this fat? It goes to the fat cells. And what kind of fat is it? It's saturated fat. That's what God decided is going to be the system. So the saturated fat goes to the cell, and when the glucose in the cells, to the fat cells, right? And when the glucose in the cells of the body is finished, they need more energy. What happens? Insulin goes down. The fat that was first transferred to the fat cells, this is, by the way, the saturated fat, goes from the fat cells to the cells. So the whole system is depending on the movement of fat from the cells, from the fat cell, from the stomach to the fat cells, and from the fat cells to the body cells. This is how we are played. This is how we are designed. We are designed to have a constant, constant movement of fat in the arteries. So how can that be all of a sudden a problem?
This is the sort of ketosis argument, being able to access those fat stores and use ketones for fuel, right?
No, it doesn't have anything to do with ketosis. Ketosis is a different story. Just the normal nutrition of humans. When you are at rest, the body uses 66% of the energy comes from fat.
Even if you're metabolically unhealthy, or is that's something that then starts to
No. If
distort the
you're
picture?
healthy, I don't know what unhealthy is, but if you're healthy, a healthy human sitting down, doing nothing, okay? The body decides, or whoever, evolution decided, right? And we're not talking only about 2.5 million. We're talking about billion years of evolution, okay? Because this mechanism is not we didn't invent it. It's there for before we became human. So
What do you mean? Can you tell us about that? Before we became human, there was this mechanism for using saturated fat for fuel.
Right. All the thing is storage. All the fat is stored in most of it is stored as saturated fat. Not all of it, but most of it.
So we see this throughout the animal kingdom as well, the rest of the animal kingdom.
Yeah, of course. And I tell you why. Because it's more efficient. Because it has more energy. Because it has more, the contacts or the connections between the hydrogen and the carbon are the source of the energy. So saturated fat has more connections than polyunsaturated fat. And polyunsaturated fat is a problem, besides because it gets oxidized and all that stuff. So saturated fat and monounsaturated fat actually form most of the fats in our body, naturally speaking, and in any animal. So this is not something that was invented for humans.
That's interesting. I mean, because I want to bring in perhaps one of the other arguments now, which is that we perhaps had certainly a drive and a want to have meat as the bulk of our diet. That's almost undisputed. But the realities being whether we could actually achieve that as the full bulk of our diet. So therefore, there was a necessity to have a certain amount of plants or fauna or other additional calorie bulking agents in our diet to bring that up.
Okay, first of all, there's only fauna or flora. There's nothing other than that. And the answer to your question, again, is very simple. And I don't understand still why people, I'm talking about people in my profession. I'm not talking about, your audience. Why they fail to understand it and why they fail to. These are kind of things that should be, the debate is not efficient because it's already solved. Look, the energetic return on hunting, and this is what studied with many hunter-gatherers, recent hunter-gatherers, okay? People followed them and measured how long it takes and what is the caloric return on the hunting. So it's in the tens of thousands of calories per hour. I don't want to name a number, it doesn't matter. The return on plants is in the 1,000 plus. Okay? So really, if we're very, very conservative, is about 1/10 of the return on hunting. Now, if you live and you go to the supermarket and you have a budget and you buy whatever you buy and you leave and everything is well. And all of a sudden, something that used to cost $1 is now costing $10. What are you going to do? You're going to starve because you just don't have the money. So that's exactly why humans could not live on plants. And I'm talking about, a period where plants were not as prevalent, as abundant as they are today. Because in the last 40, 50,000 years, there was the megafauna extinction. And the megafauna extinction actually changed the ratio of plants to animals in nature. And especially savannas disappeared. So humans that were active in the savannas, they had no choice. They just had to, energetically speaking, they had to hunt. This is they had to have this return. Otherwise, they just would not be able to survive. Today, you can find hunter-gatherers that live on maybe 20% or 30% of their calories from animals and the rest from plants. But let's take just one case as an example. The Hadza in Tanzania, I think they live on something like 30% from animals and the rest from plants. Actually, I said that there isn't any third option, but there is. This is honey. So honey is also a very important component of their diet. But if you look at the environment, actually about 30-40% of their nutrition come from one tree, the baobab tree. They eat the fruit, and the bees that are the source of the honey, most of the honey, lives on that tree. Now, it so happens that elephants hate baobab trees, and that they will be the first, baobab trees will be the first trees that they will knock down. So the only reason that the Hadza can live where they live is because there are no elephants there. And now, so people, paleoanthropologists like me, when they say that the humans were very flexible in their nutrition, they take the Hadza as an example. But you can't take analogy from a period where you don't have elephants, go back 1 million or 2 million years ago and say it was the same. It's not.
And how do you say the name of that tribe? The Haztag.
Hadza.
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 Hadza. Okay. And the Hadza tribe, have people been studying that they've always eaten like this, or has there been changes in their diet and we've been seeing like maybe new diseases coming in, or maybe improvements in health outcomes? What's been the result of that?
Yeah, well, first of all, they used to hunt larger animals that they don't hunt today, like hippos and rhinos. There's one researcher, Marlowe, who wrote a book about them, and he was really studied them for quite a long time. And he says that they are now eating much more plants than they used to. They have some problems because of the honey with the teeth, but otherwise they're quite healthy. They're quite healthy.
Okay,
yeah,
that's
they're
interesting.
Okay. They manage. Look, they eat. The fruit of the baobab. And they eat berries. A lot of berries.
Okay.
They eat berries.
Okay. Because
it depends on the period, but they eat berries.
Yeah.
A lot. Sometimes berries really form most of the diet in the season. And they eat a lot of honey. But this is untypical of Paleolithic time, of our evolutionary time. It's, they manage and they are healthy. I can't say that they have anything,
Because I think that's also something that is a nuance that is missed in certainly today's nutrition, is that people lump all plants into one category when there is a huge spectrum of plants and plant-based products. So
By the way, not only they are healthy, but you have traditional societies who live on rice that are healthy.
Mm.
So it's not that like, plants are inherently, all of them are bad for you. But what you should take into account is that, first of all, these societies live for hundreds and hundreds of years. So they had time to adapt. And you, living in Mexico or wherever you live, you don't know if you're adapted to what you're adapted. We just don't know. As long as we live in, like Japanese, that live in Japan and eat what their parents and grandparents and grandparents ate, yeah, they eat the tofu or whatever they eat there. They're healthy. Once they come to the United States and start to eat American food, they become unhealthy. So they're not adapted to American food. And I think this is the main problem. We forgot how to prepare plants because plants need preparation. All plants have toxins. And this is why we cook, not all plants, but no fruits don't, because fruits depend on you eating them to spread the seeds. But otherwise, all plants need toxins to survive. Otherwise, they would be eating themselves, or they would get eaten by other things. So the preparation is very important. And in this traditional societies where you hear that they, for instance, Indians or they eat chapati, yeah, this bread, flat bread that they have, and they're healthy. So first of all, this chapati is made of grains cereals that are low in gluten. And flat bread doesn't need a lot of gluten. You need the gluten if you want to have this like farmer's bread, the bread that has the volume. So this is the first thing. The second is that they prepare it. They eat lentils, so they wash them, they soak them, they whatever they do with them, ferment them, whatever they do with them, but they prepare them for consumption. They get rid of. They know. They don't need to know, but they know that eating them raw. By the way, any legume that you eat raw is a problem.
And this is it. This was where? Sorry, in India, did you say?
In India, but whatever, in Ethiopia, for instance, they have injera is a bread. They have some kind of cereal, not wheat,
but I've
test.
Sorry to interrupt. I've certainly heard of places, certainly like India and some African nations are starting to have increased issues with things like heart disease and type 2 diabetes and these other sort of more what we would associate with a Western style diet.
Right, because they eat non-traditional food.
Because they're eating non-traditional food, and things are creeping in, such as the substituting of animal fat-based cooking items into seed oils.
Right. This is in my opinion, the major problem. Yeah, a major problem.
And in the same way that we see a corresponding erosion of health, let's say, with the introduction of these things and the reduction of animal-based products, what sort of changes in health did we see, for instance, as humans, sort of the Homo sapiens, I guess, in sort of our developed form, started moving away from as much of an animal-based diet and towards a more of an agrarian or agricultural-based diet?
Right. It's basically the main problems that we see are in the teeth. You see caries. Because what we have is we don't have the people themselves. We have the bones. So unless the problem come to the bone and can be seen in the bone, it doesn't help if you find a 10,000 or 20,000-year-old body, you won't see disease.
But we could see things
So,
like a reduction in bone size and maybe a reduction in bone
yeah,
density and things like that.
yeah. They became smaller. They became smaller. With the agriculture, they became smaller. You can see a lot of marks that they work like in repetitive jobs, like in grinding. So you see the marks on the bones. But the main problem and the main manifestation of problems were in the teeth.
Mm.
And you see quite a deterioration.
And in terms of sort of arguments against us having sort of a heavily meat-based diet in the past, what are the arguments against that? To put you on the spot.
Yeah, boy. For instance, one of them is a gene called the ME1. ME1 is a gene that is responsible for an enzyme that is in the in the mouth when you eat carbohydrates, and it helps uh, it helps in synthesizing sugar from starch, because starch is a source of energy, but in order for the body to use it, it has to go to turn to glucose. So this enzyme, I tell you what the problem is. The first is the argument is that we have more copies of this gene than, for instance, Neanderthals. Okay, so Neanderthals are known to be super hyper carnivores. It's quite agreed upon. Although, by the way, everybody ate plants. I'm not arguing that they didn't eat plants. They did eat plants. And in my paper, I argued that about if we have to take a percentage, we ate 70% minimum of meat and about up to 30% plants. So we ate plants. And the same goes for Neanderthals. But Neanderthals had two copies of the gene. I believe also chimpanzee has two copies of the gene. By the way, chimpanzee don't eat that much starch. They eat glucose that they find in the fruit. So fructose and glucose and sucrose in the fruit. So they don't eat much starch, so they don't need this enzyme. But we have, like, instead of 2, we may have 10 copies. It changes. It's very spread. Some of us have 2, and some of us have 14 copies. So it's spread. And this is, by the way, one of my arguments against it. Anyway, so this is the argument, yeah, that we evolved to process more starch. Well, the first thing is we don't know when that happened exactly. The other thing, in my opinion, that is a problem is that exactly that it's the fact that we don't have, all of us have many copies. So there are other arguments against it, but let's say this is one of the arguments. The other argument, but this is the main argument, is the observation of recent hunter-gatherers. So hunter-gatherers like the Hadza that live in Africa and consume only 30% meat. And then there's the Eskimos that consume almost 100% meat. So humans, and we are so pleased with ourselves, we're so smart that we are so flexible that whatever the, a case that you throw at us, we will adapt. And I think this is the consensus today, and I'm going against it. But this is the consensus today, and it's based almost exclusively on observations of recent hunter-gatherer groups. And I argue, of course, like I said before, is that the environment is not the same environment. The technology is not the same. This is something we didn't discuss. But the technology, like the appearance of bow and arrow, just happened 60,000 years ago. Now, if you take into account that the evolution of human was 2.5 million years, so it's like 0.4% of the time that we were humans. Dogs, okay, appeared like maybe 30,000 years ago. So, still we have like 2.5 million years where we didn't have dogs and we didn't have bow and arrows. And we just could not, spare the time to look for many plants. Of course, women, in humans, there is a division of labor, although there are societies where humans hunt as well. But sometimes, but still, their job, their part of the division of labor, or the more important part is to watch the children, because human children needs a lot of time to grow.
Okay, so you're talking about the division of labor here between men and women, and generally
Right.
men would go out and hunt and the women would stay back and look after the children, or potentially gather. We're talking about hunter-gatherers, and they might have been in charge of gathering the sort of 30% of plant food.
It makes sense. It makes sense because you can gather, you don't have to go far away, which is dangerous. So you need to keep an eye on the children. So yes, that's also, an argument for some plants. But again, as I told you, the return on time of gathering plants is not that high. So they did gather plants for sure. But, I visited the Hadza not long ago, like last year. And I asked them, when you decide, and these are, by the way, the Hadza that meat just form about 30% of their diet. So I asked them, when do you decide to move camps? Based on the abundance of plants or animals? And the answer was definitely animals. So they dictate where you move, when to move, where to move.
And so the interesting thing about that might be that, is it 30% by choice, or the limiting factor is the volume of animals that they can catch?
Of course it is. One of the conclusions of the people that did review the ethnographic record is that whenever humans can get meat, they get it. Yeah. And it makes sense. First of all, I think it's tastier, but also
Agreed.
the return, the caloric return is so much higher. They don't have to work that hard.
Yeah.
So they can lie down and talk.
And eat a little bit of honey for pudding.
Yeah.
So the other thing I wanted to talk about, you're talking about this gene that has become more prolific. And I think the enzyme we're talking about, is that amylase?
Yeah, amylase.
So amylase. And we've also got other indications that our body is adapting to the changes in our diet since, in shorter terms that we're talking about. We're not talking about millions of years here. We're talking about thousands of years when we're having these adaptations taking place in smaller geographical pockets around the world. For example, like the lactase enzyme, which is, I can't remember which populations, but it's staying more prevalent in our bodies as we've continued to drink milk after our mother's milk. We've continued to drink animal milk and so maybe, are we we're evolving at a pretty quick rate on that level. So perhaps are we getting further away from carnivorism that we're actually adapting to a reduction of these, a reduction in necessity of meat in our diet?
Look, the question of how fast we're evolving is a good question. Are we evolving to eat legumes without soaking them first or without sprouting them first? The answer is we don't know. So nobody, not nobody, but most people don't take any genetic testings, and even if they did, we don't know what the genes are for, or we know part of them. So you have local adaptations, like for instance in the Andes, they found local adaptations to the consumption of tubers. Okay, tubers have alkaloids, they have all kinds of problems, but they have special genes that they help them to consume tubers as a major component of the diet. So yes, we are continue to adapt. We continue to to be, but the problem is that the food is changing more rapidly than we adapt. So we just don't eat the same food that our grandparents ate. You know,
Yeah.
it's interesting, for instance, that Victorian England was quite actually healthy. So people got adjusted, they got adapted, and they learned how to prepare the foods that they were problematic. But today we just don't have it. We buy the foods from companies that our health is if it's of no interest to them. And even if it were, they don't have the means to do all the research that's necessary on how to prepare the foods for us. So they add, for instance, today you take a bread and they actually don't even, the gluten that's in there is not enough. So they add gluten. So yeah, and then you compare it to societies and you say, but people ate bread for, thousands of years.
Mm.
Yeah, but the bread was not the same bread.
Mm.
And the species that we eat today of wheat are maybe 50 years old.
Yeah.
And nobody went and did like what they should do and studied that before they started feeding the whole world with this new species.
Mm.
So the food is not the same food, and we don't prepare it in the same way. So the genetic adaptation, well, if it happens, I don't think it's that significant, especially if you move away from your traditional environment.
Yeah, and we're seeing just this sort of the rise of monocrop agriculture has meant that there isn't even any diversity in our food chain anymore, comparative to what it used to be. Everything is sprayed by the same pesticides. Everything is, I think we have something like 4 to 10 different variations of wheat, corn, and barley in the West, in the US and the UK and Europe, that is just because it needs this, the same pesticides and fertilizers from Monsanto that work and don't affect the grain so that it can kill all the bugs around it. And I think there's a big tussle this is slightly off topic now, but a big tussle in Mexico with the US because there are so many different varieties of maize in Mexico. And, companies like Monsanto and I can't remember the other, Cargill, I think, or maybe they've merged now. But they want to have it all standardized so they can sell standardized fertilizer to everyone. And obviously, like when you look at it from these angles, like the priority is not human health. The priority is maximizing profit and maximizing output of calories.
Right. By the way, if you're talking about maize in Mexico, they have this process. I don't remember exactly the name of it, nixtamation or something, where they actually process the maize with some powder before they consume it. So they were aware, or they knew, traditionally speaking, that they had to do something with the maize before they consumed it.
And that's to detoxify.
Yeah, to detoxify and to so that we're able to absorb, whatever it's in there, in terms of micronutrients, not only the macronutrients. So there's a lot of knowledge, traditional knowledge, that helped us to be healthy, and we did after the sort of crisis that happened with the beginning of the cultural revolution. People learn how to live with plants. Sorry. Uh, but then we lost all the knowledge, and then the practice itself.
Yeah.
So that's my motto, is that eating meat is just a safety. It's a safety measure. I don't say it's ideal or whatever. It's just the safest food that you can have, because this is the one food that we know that we are 100% adapted to. The rest is a guess.
Yeah. And we're avoiding all the things like the potential for plant toxins, chemical fertilizers, pesticides, all of that stuff. Even if some people are saying that there's hormones in the meat and there's, antibiotics that are leaching into the muscle, which I don't believe is proven.
That's BS.
Yeah.
That's just
and
not good.
one other thing I wanted to touch on, if we're rolling back to when we're looking at different animals and we're looking at things like their digestive system to try to understand what they're adapted to digest, I wonder if you could touch on things like stomach acidity when compared to, a gorilla who's only eating fibrous plants versus a human or a dog or a cat.
Right. This is in the when you want to reconstruct the diet, you have to, I mean, the tendency until today by my fellow scientists was to try to reconstruct the components of the diet. But I thought that not all of them. Some of them also went with the same attitude, but I think I took it to a level that was not done before. But the attitude is this: instead of trying to find item by item what people ate, try to see the trophic level. So what is the trophic level? Trophic level is your position in the food chain. So herbivores that eat, herbs, or eat, plants, they are like, they get the number one. And the people or the animals that eat herbivores, they are like two. So every level. So and the animals that eat carnivores, there are three. So this is the trophic level, okay? So if you ask what trophic levels humans were, you're freeing yourself from trying to identify item by item what they ate. And this is where the story of this acidity comes into play. Because some other people did the research and tried to find what is the association between the acidity of the small stomach and the trophic level. And they looked at, let's say, elephants, and the acidity was very low. And they know that the acidity, one of the roles of the acid in the stomach is to fight pathogens. So they found out that carnivores have higher acidity than omnivores that eat, both plants and animals. And scavengers have higher acidity than carnivores. But really, carnivores and scavengers have very high acidity. It's pH of 2.2, and then 1.5. This is what we had. the higher the pH, the lower the pH, the higher the acidity. So it turns out that we have the acidity not only of carnivores, but actually even a higher acidity than carnivores. Now, to keep a high acidity, our stomach cells have to change like every 4, 5, 7 days just to keep with the acid environment. So it's not something that is done, just for the fun. It means that we needed it. And so the author of that paper said, oh, it looks like humans were scavengers. But she doesn't know much about, about hunter-gatherers and etc. She knows more about acidity. And human hunter-gatherers are very special carnivores. They take the animal away from the place where it was killed. They move it to a camp, and they sit on it and eat it for days. Depends on the size. So let's say if they eat an animal that has 100 kilos or 200 pounds, they can live on it for 2 or 3 days. A larger animal, let's say 800 pounds, they can live on it for 2 weeks.
So that indicates that we were both carnivores in the terms of we hunted the animal and then we switched to this almost scavenger stage where it's almost as if we've just come across a freshly killed carcass and we eat in that manner.
Right. And it also proved that we ate large animals.
Large prey.
Yeah. So in this way, if you start to look for things that separate carnivores, any carnivore, from omnivores and from herbivores, you can determine whether we were carnivores. You don't have to actually measure the amount of meat, that they ate, which is impossible.
I think my camera might have just gone then, but
yeah,
there we go.
Okay,
I'm back. It's all right.
Yeah. So we are free from just trying to count the number of bones in the sites, and we can look, because so there are other things like that, like the structure of the fat cells in our body. So omnivores have a certain number of fat cells to store a certain amount of fat. Carnivores have more than double the number of fat cells, but they are smaller to store the same amount of fat. Humans have the same structure of carnivores. Okay, so we are, this is the proof. You don't have to go that far further from that. You don't have to count, because there's no way that in archaeology you can reconstruct what was the relative quantity of plants and animals, because plants were eaten all over the place. You don't have to bring it back to the camp. You just eat it. And also plants don't preserve that well, so there are not many plants in any way. So there's no way to tell the relative quantity. There is, if we talked about arguments for plants, recently, like in the last 10 years or so, researchers started to look at the plaque in the teeth that they find. You can find 400,000 years old teeth, and you look at the plant, at the teeth, at the plaque, and you find plants that are stuck there in the plaque. And they say, oh, you see, they ate plants. First of all, nobody argued about that in the beginning. But there's no way to tell what was the relative quantity of plants to animals. Sorry. And these kind of evidence, the one that we discussed just now about the fat and the acidity, allow you to say that humans were carnivores. Now, how do you go from that? But again, unfortunately, it doesn't tell you exactly how much. And here I took another analogy. Now, it can be, I mean, people can argue about this step, but this is the step I took. And I said, okay, so we were carnivores. So I looked around and I looked at the carnivores. So large carnivores and social carnivores. This is us. We weigh, let's say, 80 kilos or 60 kilos. 60 kilos to 80 kilos is a wolf. So it's a large, considered quite a large, although, of course, lions are larger.
Mm.
But we are large carnivores. They're smaller, like foxes and smaller carnivores. So we are large carnivores and we are social carnivores. And when you look at large social carnivores all over the world, all of them are 100% carnivores. All of them are at least. So my conclusion was that if you are a social carnivore and you are that big, you are, hyper carnivore. Sorry.
That's okay. And obviously knowing what you know now, like you had this career in the sort of finance industry, and during that time, were you eating in a carnivorous way, or were you eating like a regular Western diet?
I was eating, I was eating, what were they called? No, complex carbohydrates, because that's what they told me.
Mm.
Yeah.
So, and now, how is your diet? I think I could probably guess how your diet might have shifted, but what's your diet now?
Uh, the maximum carnivore that I can be.
Okay.
I'm eating ice cream from time to time, but really, most of my calories come from meat.
Okay, and you felt a change, a health change?
Absolutely.
Yeah.
No, the change, my change was almost exclusively weight a little bit. I lost some weight, but I was never really fat uh, in attention. So I had a very difficult, very severe attention deficit disorder. When I was a student, I was offered to become, to come to and become part of the team and go to university and, become like have academic career. But it took me 2 years to do one small, work. So I said, this is just not for me. I just don't have I just can't sit down for hours and do, academic work.
Mm.
But since I moved to this kind of eating, I do it with no problem whatsoever. I wrote a book about 12 years ago. And it's a book about hunter-gatherers and why we should learn how they live, not from a food point of view, just from an emotional point of view, things more softer aspects. And half of the book I wrote with Ritalin. And after I discovered this way of eating, I uh, I didn't have a need for the Ritalin anymore. I just threw it away.
Wow.
And yeah, and I wrote the other half of it. So yeah, for me it was that was the main.
Yeah.
And by the way, I'm translating this book to English now,
Oh, wow.
and hopefully it will come out in a few months.
What's the name of the book?
Oh yeah,
Or you're yet to title?
yeah, I've yet to title it. It's something probably I'll use my Paleo Style brand name in one way or another. But I don't know what it will be yet.
Fantastic. Well, we'll look out for that. But Dr. Miki Ben-Dor, thank you so much for taking the time to talk today. If people if you've sparked an interest in people, you're saying stuff that they want to engage with more of, where can people find your work online?
I have a blog which is not that active anymore, called paleostyle.com. And I'm active in Twitter. That's where I can be found mostly.
Fantastic. Dr. Miki Ben-Dor, thank you so much for your time.
You're welcome.